In this video, we discuss JavaScript closure. Most of us finds this topic confusing. Everyone wish if it were more easy to understand, because it is one of the fundamental concepts regarding JavaScript functions. Here we have discussed everything you need to know about JavaScript closure without leaving a confusion. Things like what is a JavaScript closure, does closure is the only for nested functions, difference between lexical scoping and closure, why we need JavaScript closure so badly, etc. Everything is explained with the help of diagrams and practical examples. I have spent a lot of time making this video, so if you find this video helpful, which I am sure of, please consider subscribing to this channel CodAffection. Please like and share this video with your friends and colleagues. Without further ado, let's get started with the topic. First of all, as a prerequisite to JavaScript closure, we have to thoroughly understand what is scope chain and lexical scoping. As you know, scope means availability of a variable or a function. We have already discussed the scope of variables declared with various keywords like let, const, and var. There we had three kinds of scope: global scope, function scope, and block scope. In brief, block scope is only applicable to let and const variables, not for var variables. Both global scope and function scope are applicable to all types of variables. Now let's discuss availability of a defined function. Now consider this function A. It is defined in global scope, so it will be available throughout the global scope. Now let's enclose this function within a block statement like this. As you can see, still this function is available outside this block statement. So a block statement does not limit the availability of a function to the outside. Now let's enclose this function within another function. Let's call it as function parent. So here we have nested this function A within this parent function here. So such types of functions are called as nested function, and this outer function is called as parent function, and the functions within it is called as child functions. As you can see, this child function A is not accessible to outside this parent function here. Now let's move this function call to this parent function here. Now we have to call the parent function after all. Now this child function is getting executed with this function call here. So a child function is only accessible within its parent, unless if you return the function. If you return the function, the return function can be assigned to an outside variable and can be invoked anywhere as long as the assigned variable is available. So that's a different case. We'll be discussing such functions along with JavaScript closure. So far, based on where the function is defined, we have discussed the availability of the function to invoke. From now onwards, we're going to discuss scope of variables defined within the function using the terminologies scope chain, lexical scoping, and closure. Now let me remove this parent function here. Now inside the function, let's declare a variable y and let's initialize that with 2. Now let's print the same here. Now this local variable y is only accessible within this function here. But there is also an exception. If you return this variable y, its value can be accessed outside the function. There is no complication regarding returning a variable from a function. But if you return a function within from another function, then there are some complications. We're going to discuss that along with closure. For now, we have a normal function. Now if you try to access this variable outside this function like this, as you can see, it's not possible to access local variables of this function outside the function. So let's move this statement back to the function here. Now let's talk about scope of this function here, meaning what are the variables that can be used within this function here. Of course, local variables or parameters for the function are always accessible within the function. Now suppose we have another variable x outside the function. So outside this function here, we have global scope. So this x variable is within the global scope. Now if you try to access the same within this function here, it's possible to access global variables within a function. To put this into a statement, we could say scope of a function is the sum of its local scope and scope of outer function or global scope. For this function, the outer scope is global scope. As mentioned, when a function is nested within another function, the outer scope will be the parent function scope. We're going to see that in a bit. So this is how internally JavaScript manages those function scopes. So here we have the function A and the corresponding local scope is represented within this block here. Inside the scope, we have a single variable y The outer scope of this function is global scope, which is represented with this block here. Within it we have a single variable x. Now inside these scopes there will be a reference to its immediate scopes. So for this local scope, the immediate outer scope is global scope. So here we have the reference to it. In any case, there won't be another scope outside global scope. So that's why we are not seeing a reference like this here. So this is how a function manages its scope. All of its outer scope and local scope are interlinked with a reference like this. Now inside this function, let me declare a child function, inner function. Inside that we have a single variable z initialized with 3. And let me rename this parent function as outer function. So here we have called the parent function here. Now inside the parent function, let's call this inner function or child function. Now let's discuss scope of this child function here. As we already stated, scope of a function is the sum of its local scope and the scope of outer function or global scope. So inside this function, we can access its local variable without a doubt, so which is z. As per this statement, scope of the nested function can be represented like this. Here we have the inner function or nested function, and this block here represents its local scope. Inside that we only have a single variable z. Now the scope of this function is the sum of its local scope and the scope of outer function. Now this block here represents the scope of the outer function. Inside that we only have this single variable y. Now the same statement is also applicable for the scope of this outer function also. Here we are considering the scope of the outer function, which is then added to this local scope of this inner function. So scope of this outer function is its local scope plus its outer scope. So for this outer function, its outer environment is global scope. So here we have the global scope also. Inside that we have the single variable x. So scope of this inner function is sum of these scopes here. All of them are interlinked with a reference like this. Now this chain of scopes, or you could say sum of these scopes in this hierarchy, is called as scope chain. All of them are interlinked with a reference like this. So this is what we call as scope chain. In previous example also we have a scope chain including local scope and global scope, which is interlinked with this reference here. Now back to the program here. When we say scope of this function is sum of this local scope and outer scope, means we can access all of the variables in those scopes here. So we can access y here. You could see its value printed here. You could access the global scope also. So that's what we meant by the scope of a function. So in this way, this function can make use of its local scope or its outer scope in the scope chain. Now before discussing JavaScript closure, there is one more important topic to be discussed, which is lexical scope or lexical scoping. Now let me comment this function here. We will get back to this later. Now consider this program. We have a variable a. Now let's define a function to print the value of this variable a. So here is the function print a. So here we have the log statement. Within it we just need to print the value of a. Now suppose by mistake we are defining the same variable a inside this function itself. Now if I call the function here, what will be the output? Will it print 0 from this outer variable a or the inner variable a with 1? Now let's uncomment this. You see it is printing the inner variable a1. It's because of lexical scope in JavaScript. That means scope of a variable is determined at compile time based on the location where it is defined. Whatever the value of this variable a, this function print a will always print the value of this inner variable a here. Here we have two variables with the same name a. One is declared in global scope, one is locally declared to this function print a. Now when we access the same variable a within the function, it will be always referring to the local variable a here. That's what lexical scope. Variables are mapped to the declarations based on the location where it is defined in the source code. The process of mapping a variable name or identifier name to the declaration is called as lexical scoping. and this process is done at compile time because JavaScript can easily determine which variable is referring to based on the location where it is defined in the source code. So that's what we have here, the process of defining how variable names are resolved or mapped to their definitions. So that's what we have meant by lexical scoping. The exact opposite of lexical scope is dynamic scope. JavaScript is a lexical scoping language. There are some languages where variables are mapped to their declarations based on where they are invoked rather than their declaration location. So it can only be done at runtime. So that's what dynamic scope means. Now if I remove this local variable a here, then it will print the outer variable a, because there is no other variable a to map to. Now let's explain lexical scoping with our previous example. So let me get rid of this and let's uncomment this program here. Currently inside this inner function we are accessing the variable x, but it is defined in global scope here. It's nowhere defined inside this outer function or inner function. So during lexical scoping, the JavaScript engine checks whether this variable x is defined locally to this inner function here. No, it's not defined. Then it will go to the immediate outer scope of the function as mentioned in this scope chain here. If the variable is not here, then it will go to the outer scope. The variable x is not present here, then it will go to the outer scope here. So that's how scope chain works, and this process of mapping this x variable here to this declaration defined in global scope is done at compile time. So the process of lookup will be like this. Here we have the inner function and we are calling the variable x here. There is no local variable with the name x. Then it will go to the outer scope. There is no variable x, and it finds the variable x in global scope. Now consider this as case 1. Now here we have the case 2. We are declaring the variable x within this outer function along with the variable y. So here we are defining the variable x, and let's initialize that with 11. Now this time this x is mapped to this parent variable x here, because in this scope chain the parent variable x comes before the global variable x here. So based on the location where these variables are defined, JavaScript determines which x is referring here, this one or this one. Now here we have the final case. We are swapping these two functions, inner function and outer function. See, here we have the inner function in between global scope and outer function here. Now let's modify this program accordingly. Let's move this outer function as a child function to this inner function here. Now let's change this function invocation order. So this time order is different. See, this time it prints the outer variable x value 1. Since the order of the function is changed, the variable is getting accessed even before this function outer function, which is the child function in this case for this function inner function. So this x mapped to this outer scope x here. So this is how lexical scoping of variables works based on the location where they are defined. Now that's been discussed. These are the prerequisite topics for learning JavaScript Closure. Now, with what we have learned, explaining JavaScript Closure becomes more easier. Let me get rid of this existing code here. Here we have this function fun. Inside that we have a variable a initialized with 1. Now we have the child function print a. Here we have the log statement. Now let's call the parent function here. Now inside the parent we have to call the child function print a. As a result of that, this parent variable a is getting printed here. Now instead of defining and invoking this function here, I'm going to return this function from this parent function here. When returning a function like this, I prefer returning anonymous functions like this. The same function will be returned while invoking this function here, so we can access the return function with a variable like this, print a. Now you see, we can call this print a function, which is actually this return function from here. It can be called anywhere inside this program, even after 1000 lines of code. As long as the variable print a is available, this function can be invoked without a problem. See, in this return function here, we are accessing the parent variable a. In previous case, we have defined the function here and we call the function inside this parent function itself. But now instead of defining and invoking the function inside the parent, we are returning the function. So with this statement, the parent function is getting executed and this function is returned and it is assigned to this variable. Now when we invoke the function, say after 10,000 lines of code, print a is invoked here, the value of a is getting printed here. How is it possible to access the value of this a when it is defined in the parent and the execution of this parent is done with this statement here? How is it possible for this function to access this variable a in the outer function here? Is it a ghost? So that's what I'm being doubtful here. Don't you feel the same? So that's where JavaScript Closure comes into the picture. Since we have learned lexical scoping, you might be thinking this variable a is referring to the outer scope variable or parent function variable a. If you think so, you are 100% correct, but it is made possible physically through JavaScript Closure. The concept of lexical scoping is a rule which explaining how things should be working, but through JavaScript Closure it is made possible physically. JavaScript Closure gives the access to this variable, outer variable a, even after the outer function execution is over. So here we have the official definition from MDN. A closure is the combination of a function bundled together or enclosed with reference to its surrounding state or lexical environment. Pictorially, you could represent a closure like this. It is a bundle consisting of function body or function definition along with the variables that this function is depending upon. The data structure that hold the depending variables are called as lexical environment. Now back to our program here. In JavaScript, every function has a closure. For this return function, there will be a closure. Inside that closure, this function definition will be there along with the variables it is referring to. So in that closure, a reference to this variable a will be there. So that's how this function is able to access the value of a even after thousands of lines of code here. So that's how a function closure remembers external things that is used in the function. The required variables will be preserved in the corresponding function closure. It's like a backpack. Wherever you go, it will be there. So no worry, function carries everything it needs for its further execution. Now talking about this lexical environment, it's actually a data structure holding these variables required for this function. Don't think that both lexical scoping and lexical environment are same. Lexical environment is a data structure that holds identifier mapping information, and this mapping is defined through lexical scoping based on the location. That mapping is physically stored in lexical environment. So basically, which is storing the dependent variables for this function here. Now actually I can show you this closure in developer console of the browser. For that, first of all, we have to put a breakpoint inside this return function here. So inside this developer console, go to the tab sources, then put a breakpoint here. Now let's reload the application. So currently we are at the breakpoint. Now under this scope here, you could see this closure containing the variable a. With this statement, the parent function gets executed and this anonymous function is returned to this variable. And now JavaScript is in the process of executing this function. Unfortunately, we put a breakpoint inside it and now here we are. Even though the parent function execution is over with this statement, since the return function is depending upon the parent function variable a, the closure contains a reference to the variable a here. So that's how this closure works. Now hope you are convinced with my explanation. Now do you have this doubt? Does JavaScript closure is only available to nested functions like this? No. Every function in JavaScript has a closure, whether it is nested or not. Everyone explains closure with nested functions because it is easy to explain the concepts. Now to prove my statement, let's remove this debugger and back to the program here. Let me replace this function with this increment function here. First of all, we have this counter variable. Here we have a simple function increment. Within it, we will increment the global variable counter and it is getting printed to the developer console here. So that's the simple program here. Now let's prove my statement that every function has a closure. To prove that, there is a straightforward method by just calling this console.dir function. Inside that, just pass the function name, which is increment. Now this function can display list of interactive list of properties specified for the JavaScript object. As you know, JavaScript functions also comes under the data type object. So we can call this function to see what is really happening inside the function. Now here we have the interactive list of properties of the function. Now this is what we are talking about. Under this scopes, you could see various variables that is depending upon. Here we have two scopes that this function increment is depending upon. Now if you expand script, you could see the dependent variable counter here. Now I'm running this JavaScript file commonpractice.js within index.html. Since I'm using a script file to run this JavaScript code here, whatever variables from this file will be listed under the scope with the name script. If you are running this JavaScript code within an HTML directly, then the variable counter will be there under this global scope here. So this variable counter is shown as part of the function closure. So that's kind of prove my point. I know you are not fully convinced with my explanation. For that, I'm modifying this program to modular design pattern. Don't worry, it's not that complicated. I will give you the necessary brief introduction and we'll be discussing the modular design pattern in a separate session in future. So within this HTML, we have referenced this script file script.js. In my case, I'm using a different name for this file. Most of you might be using this name script.js, and here we have another file counter.js. Within it, we will paste the function that we have just created, which is increment function. Now if you look at this definition of the function, along with the function here, we have these keywords export default, so that this function increment can be exported from this file counter.js and it can be imported in another file for further use. So that's what we have done within this script.js file. Import increment function from this given path file. You see, just beneath that we can call the function like this. So that's what modular design pattern works. We can import functions or objects that is exported from another file. So let's do that here so that you can clearly understand my point. Now let me cut this function from here and let's paste that inside our file counter.js, which I have already created, and let's paste the function here. Now first of all, we have to export this function from here. So we just need to do this export default. So here we have exported the function increment. Now let's import the same inside this import increment from counter.js. Now let's call the function here increment. And also I forgot to mention something. Inside the index.html, while referring the script.js file path, inside the script tab we have to add this attribute type is equal to module. It's part of modular design pattern. I just want to know you this, whatever we have done here, it's completely legit. I'm not using any external package. It's completely possible with plain JavaScript. We'll be discussing more about modular design pattern in upcoming sessions. As you can see, the function is working and this function is getting executed twice. It's because we are calling the same function here also. So let's remove that here. So we have defined the function increment and it is exported from this function counter.js, and the same function increment is imported inside the script file and we can call the function whenever needed. So that's how modular design pattern works. Now to prove my point, I have to place a debugger inside this function here. So go to source tab. Let's expand this developer console. Here we have the files and inside this counter.js file we have the function. Let's put a breakpoint here. And let's reload the application. Now under this scope, we have local, which is local scope. Since we are using modular design pattern, we have a scope called module. Inside that, we have the function increment along with the dependent variable counter. As we can see, the variable is declared within this counter.js file and which is made available for this exported function increment when it is invoked here. And also inside this scope, it's not always necessary to list closure variables under the name closure. It only happens for nested functions. Otherwise, like we have seen before and this time, it will be listed under different scope names like module or script. So wherever this function is made available, whether it is returning from a parent function or whether it is exported from a file to a different file, the dependent variables are remembered through the function closure like this. So hope you are convinced that all functions has closure to remember dependent variables. Now let's get rid of export and import. Let me cut this and pasting here, and let's remove this export keyword here. Now here we are back to our previous program. Now do you know why JavaScript Closure uses the word reference to surrounding state rather than value of surrounding state? Now that's also an important topic to be discussed. So back to our program here, and let's create a function to generate counters. So we will define this function generate counter. Inside the function we have this variable counter, and which is initialized with 0. Now we have few functions for incrementing or decrementing or displaying the counter value. So these are those functions. All of them are defined with arrow syntax. So first of all we have increment, which is just to increment the counter variable here, and then we have decrement for decrement the counter. Set function is used to update the value of the counter, and finally with this display function it will just display the value of the counter. Now we have to return all of these functions here. So all of them can be returned together with an object like this. So increment is equal to increment function. When the assigned component has the same name as that of the property here, then we just need to do this. Increment, then decrement, set, and display. Now we can create counters with this function generate counter. So here we have the first counter, counter 1. We just need to call the function here, and all of these functions along with this variable will be returned. Because all of these functions are using the variable counter, so the closure of these functions will include the variable counter. So that's what we have learned so far. Now to see the value inside the counter variable, let's call the function display. So counter1 dot display can be called. Sorry, I forgot to mention the keyword const here. So to do that in a one step, you just need to place the cursor at the first line and just use the shortcut hold Control then Alt, then use the downward arrows like this. So then all of the lines in the same cursor place will be selected. Now we just need to type const here. Okay, we have called the function display. As a result of that, the value of the counter variable is get printed. Now let's increment the variable. For that we can call this function increment. After the increment, the value should be updated to 1. You see that, let's move this display statement after increment. Now you could see the value as 1. Now let's decrement the incremented value. It is again back to 0. Now let's set that with a given value. Call the function set and pass the value here, something like 10. Now from these function invocations, it is clear that all of these function closures has a reference to this variable, not the value of the variable here. That's what we have seen here. After calling the increment function, the value of 0 is get incremented to 1. Then the same variable is getting decremented after calling the decrement function. Suppose if the function closure has value of the counter instead of the reference, initially all of these function closures will be having the value 0 like this rather than the reference. So when this function increment the variable 1, it will only happen at this function increment here because it is having the value rather than the reference. So that's proved the point. Closures remember the variable through reference rather than the value. Now let's remove some of these functions here. Now let's create one more counter, and this time we will call it as counter2. Now let me copy this and pasting here. Instead of increment we will call decrement. Now let's change counter1 to counter2. See, here we have created two counters, counter1 and counter2. With counter1 we have called the function increment, so the value is get incremented to 1. Now with counter2 we have called the function decrement. You see the value is getting -1 because 0 is getting decremented to -1. Now my point is that these two counters has created different closures for these functions here, because we have called this function generate counter separately for creating these two counters here. So this function invocation here will create a separate closure for these functions here. And here we call the function again. So these return functions here will have a different closure. So that's what we have seen here. Let me remove this decrement statement from here. We have incremented the counter. The value of counter 1 is displayed as 1 here. At the same time, counter 2 is 0. So which is not incremented with this counter 1 increment function here, which is clearly mentioned after the definition here. Closures are created every time a function is created at function creation time. So each time we call this function parent function, these functions are created with this return statement here. When we call this generate counter each time, it creates separate set of functions with this return statement here. So that's what happens here. Both these functions create separate closures. Now to prove the same, I can show you another example from MDN. For that, first of all, let me comment this one here. We will get back to this example later. Now let's copy this example from MDN. So here's the function makeAdder, which is a parent function. It has a single parameter x. Inside that, an anonymous function is getting returned. The return function also has a parameter y. Inside the function, both x and y is getting added and the result is returned. So the function is invoked twice here. makeAdder with 5. makeAdder with 10 is invoked here. So currently inside this variable, there will be a function like this. So currently the closure x is having the value 5. Now when we call this add 5 here with this parameter 2, then 2 plus 5 returns 7. Here the function, same function makeAdder is again called with another value 10. As I mentioned before, each time the function is created with this return statement, a new closure is created. So this time inside add 10, the created function will be having a different closure with the value 10. Here we have called the function add 10 with the same value 2. So 2 plus 10 returns 12. So each time we call a function, it creates a closure. Here invoking these parent functions here, in effect, return the function which happened to create the nested function here. So along with that, a new closure will be created. So that's all you need to know about JavaScript Closure. Now let's discuss benefit of using JavaScript Closure. Why we need them so badly. So the first benefit is that it can save partially executed functions. You could see the same inside this example here. Let me get rid of these here. So we have called this function makeAdder with 5, and the return function here is saved into this variable add5. Now this variable has a partially executed function. It can be used in rest of the program to add a value to 5 like this. Like this, we can add any number to 5 with the same function. Because of JavaScript Closure, it can remember the dependent variables even if the variable is declared outside. We have seen the same inside our modular design pattern. From this counter file, we have exported this function increment, and the function is using the outer variable counter here. We can make use of this exported function in another files when we import, since this function remembers its dependent variables through its closure. Now actually I can give you more examples from React or Angular. Considering the bigness, I'm not going to frighten you with React or Angular. We'll be making separate tutorials for React and Angular. We'll be discussing these topics there also. Now the second benefit of Closure is this modular design pattern itself. It made possible to export a component from a file and importing the same in another file. Since this function is depending upon the variable counter, the function creates a closure, and that's how when we invoke the function in another imported files, it remembers this counter, and that's how this function is getting executed. So modular design pattern makes use of closure. We'll be discussing this pattern in a separate session. Now back to our previous example of this counter here. Now the third benefit of using JavaScript Closure is that it creates data encapsulation. Inside this function we have this variable counter, and to work with the variable we have these much 4 functions. Now outside this function, this counter is a private data. It can only be accessed with these functions here. Now if you want to prevent this counter variable from getting updated by mistake with this set function, you can remove this function from here and the problem can be solved. So this is how data encapsulation can be implemented, and JavaScript object-oriented programming make use of this data encapsulation in a great depth. So that's all the important benefits of JavaScript closure. So here we wind up this video. In next video, we'll be discussing iffy in JavaScript or immediate invoking function expressions. Thank you so much for watching this video. If you found this video helpful, please consider subscribing to this channel. Please like and share this video with your friends and colleagues. See you in next video.